All right, good afternoon. Hope everybody enjoyed their lunch. I'm Bob Anderson. It's my pleasure this afternoon to introduce you to Tom Lantzsch, who's Executive Vice President of Strategy at ARM. Tom had a successful career prior to joining ARM in 2006. He was CEO of a company called StarCore. Prior to that, worked in 4 different countries in sales, marketing, and operations for Motorola. Began his career at Texas Instruments. Up until now at this conference, we've been hearing about the next digital world where everybody's going to be doing lots more stuff, and somebody's got to come up with the capability to deal with all of that flow of knowledge and information. Tom and I kind of looked at what industries could be affected, and we couldn't find any that were not, whether it's education, healthcare, your home, your automobile, the power generation, the grid, household appliances, military. Everybody is playing here. Last year, ARM's IP went into 9 billion semiconductor chips around the world, going into mobile devices, low-power sensors, and enterprise equipment. Now, Tom tells me he has a way of telling the future in the computer business, and it's a unique result of their business model. So, Tom, why don't you share with us how it is as you know what's going to happen in the next 5 to 10 years?
Well, that's a tall order. So, first of all, thank you for the introduction. Let me give you a quick background of, just for the audience, of who ARM is and what we do, and why I think we have somewhat a unique position of somewhat anticipating some of the changes that will become available to all of us. So ARM is a 22-year-old company. We design microprocessor technology. We don't build chips. We sell those designs. We have over 250 licensees around the world that build semiconductor products. So the analogy would be, whereas in the context of Intel, because we all know who they are, they would design a Pentium core and build it in an Intel fab. We would design a Pentium core and sell it to anybody that wants to make semiconductor products. Our history as a company uniquely found ourselves with our licensees taking these technologies and putting them into initially mobile products, which drove a focus in our company on creating high-performance, energy-efficient designs. And so today, most all of you have probably touched ARM technology in multiple ways, probably multiple times today. The average cell phone has about 6 of our cores in it today, so it's pretty diverse. Now, why is that interesting to the group? Due to our business model and what we do on designing these products, our engineering team working on product development today are working on products that you won't see in your hand as a consumer until probably 5 or 6 years from now. It's not even our R&D team. This is just product development team. And the reason for that is the time that it takes for them to do a design may be 2 years. By the time we hand that product over to a semiconductor partner, it will take them 2 years to design and manufacture a chip. By the time that gets in the hands of somebody making an end equipment product, it may take another 12 to 18 months, and that's sort of how our business works. So we're working on this time horizon, and our time horizon is somewhat way out in the future. And that sort of puts us in this unique position to understand where technology is going, largely because we're working with our customers.
What are the market drivers that you folks have to respond to?
Yeah, so when we look at computing and look at the where we entered the market, so certainly computing, we look at it in waves, if you would. Certainly the first wave was productivity enhancement. We all saw that with the advent of the PC industry and the impact that's had. Second wave, which is sort of the one that we're in right now, clearly known as the mobile wave, I sort of look at it more than broadly than the mobile wave. I really look at it as it's almost a social democratizing of technology wave. I think it's much more than mobile. The fact that the device is mobile is interesting, but the fact of what it is impacting with the combination of social networking and all the things that we talked about today, and taking pictures, etc. That's sort of the wave we think we're working in, and we'll be in that for a while. The next wave, which is sort of the one that I spend most of my time on now, is commonly known as the Internet of Things wave. I tend to look at it almost in a social context. This is really the wave of adaptive learning, really creating closed loop systems, either at a personal level or at an industrial level, that makes things much more efficient. Underpinning all those technologically is this focus on power, efficiency of power, which is going to be critically important to everything that we do in this room, because the raw demands that we are putting on compute technology from the cloud all the way to the smallest of sensors will certainly have an impact.
You shared with me some information about how many cell phones it takes to require a new server to back it up. I was kind of amazed by that.
Yeah, somebody was mentioning this a little bit today, but Intel has reported, or they've done some analysis, we've done some similar work in this space, that with smartphones, every smartphone that goes into the market drives about 600, for every 600 smartphones drives a server demand. Similar numbers for iPad type devices, again using cloud-based services, is about 125 to 1. So as we expand this portable connected world that we're all involved in, it's beginning to have, as we know, huge impacts on the demand of the data center and the server demands in support of that.
I'm quite interested in your closed loop control commentary. I'm a chemical engineer, so I know about controlling things like temperature and pressure and flow. And I understand how my thermostat works at home. What are you talking about when you close the loop to be controlling things?
Yeah, so we're starting to see some of this now. The Fitbit thing is sort of an interesting example. I think it's the first example we talk about today. We see a world that we want to enable, or we're working on enabling, where the world will have billions, literally billions of internet-connected devices. So whereas today the mobile market is largely driven by the number of people on the earth, we see a world where there is going to be almost an infinite supply of small internet-connected devices. Those devices will feed into, at some point in time, large cloud-based data centers. And at the essence of that, there will be some type of actions taken upon this information. The Fitbit one I think is interesting, and I'll sort of talk about where we see it somewhat, it's interesting today, but we see fundamental change still occurring. The Fitbit one is interesting today because nonetheless, I mean, people are taking that information and adjusting their lifestyles. And it's really limited information. Personally, I'm somewhat of an athletic guy, so I've sort of gotten into these gadgets early on, and I'm always amazed. 2 years ago, would I really have understood that if I ran a mile as a 53-year-old guy at my pace, how many calories that burns, which in my case is about 109. I know the number. I would have never understood that. And then compare that to the chocolate chip cookie that I see when I go to the Starbucks store at 350 calories. It is having an impact on that decision process, right? And that's just a small, that's a very small token of how these closed loop systems are beginning to happen, not only at a personal level, at a professional level, at a technology level. We're seeing this expand as greater and greater efficiencies are required as companies want to offer services that are more and more predicated on services versus just the product themselves. An example of a project we're working on right now is streetlight lighting, of all things, where municipalities changing light bulbs in an organized manner is an efficiency gain that can be had with municipalities. Or, it will eventually get to shutting off those lights when there's no cars on that road. We're not near there today, but these kinds of things are just going to become more and more pervasive, and it's all going to be about closed loop engineering, which most of us and many of us in this room are engineers. We know that closed loop systems allow us to make decisions faster. And with decisions making faster, we just become more and more efficient, and we learn from those and constantly change. So I think this evolution of closing the loop, if you would, on technology is going to be this next wave. And it'll take, this is 10 to 20 years from now before these things really become significant. We'll see spot solutions along the way.
You and I discussed the General Electric model where they don't sell airplane engines anymore. They rent power by the hour, they monitor the performance, they fix them when they need fixing, they don't fix them if they don't. Airline company writes a check, and it's all done. I think you see that happening in lots of other machines, other automobiles, you name it.
Yeah, and GE happens to be the one that's working on this lighting example,
okay.
to be honest with you. And again, I think it's an issue of companies being able to act upon data. We talked about big data, act upon big data to provide services to their clients that are in this realm of becoming more efficient as providers. Certainly we'll see that, similarly we'll see that in the healthcare field. I find the Fitbit, get back to Fitbit for example. Here are the challenges that we start to see with these things. I mean, technologically, I don't think we're going to have huge challenges. We know how to do these things. Somebody was talking about hardware security. We were mentioning that today. Mm-hmm. ARM-based, our cores, we have been selling hardware-based security since 2002. We knew this was coming. I mean, we shipped 9 billion products last year that have the ability to do exactly the kinds of hardware-based security that was talked about by some of the previous guests. The fact of the matter is no one's taking advantage of it. It's just sort of dormant. So it won't be a technology challenge. What will be a challenge will be when we have something like your heart rate. Let's take a simple one as an example. It's real easy, as part of a heart rate monitor on an application. We used to have them for fitness. Polar offers them all the time. That's all great. Now the question is, as a consumer, who do I want to pass that heart rate information to? How do I make that decision? How do I pass, do I want to pass that to my insurance carrier? If I did, what benefit would I get? I only have one heart rate monitor. So now the trick is going to be, we really see the trick is going to be, and somebody was talking about security and authentication and authorization, and how when you have this world of highly connected devices, who gets to know what information? And this is an area where we're spending quite a bit of time thinking about it, because the control of that information, and we ultimately won't do that, but what we want to make sure is our technology enables this information to be controlled in that manner. And who wants to decide? Everybody can tell right now that where you are based upon the GPS in your phone when you're driving down the road. Generically, we're probably all fine with that if it's used for traffic information to determine if my route is the right one, because now I'm getting real-time demand signals from the highway, which is good. So I know if there's a traffic jam because somebody slowed down up there, and we can do that. I don't know that I'm happy about the fact that somebody knows it's me. And under what rights do I want them to know it's me? And maybe I want to know that my 18-year-old son, where he is, but he doesn't want me to, and so who gets to decide? So I think this to us is the real challenge, if you would, going forward in this world. We know how to do all this stuff, and getting to those solutions are going to be the ones that are going to retard the deployment of many of these systems.
Let me move over a little bit into the developing world. We've talked a lot about sophisticated societies, and you told me a story about the fishermen in South America that was just fascinating. Can you share that with us?
Yeah. For those of you who don't know, we look at the world through a mobile eye, which is our predominant market today, and I don't know what the actual number is this year, but last year or so ago there were about 5 billion phones in the market, of which 80% of them are in developing countries. So I sort of always look at that marketplace because, frankly, it's a little more interesting to me. But it talks about how people are using technology outside of developing countries for innovative solutions. So the fishing one was actually a South American example, where fishermen off the coast of Chile, I think, or I think it was Chile, actually, when they do their catch, at the end of the day, they catch fish, and before they come into a port, they basically have a text-based service that determines they know what they caught, and they know who else has caught stuff and delivered to that port that day. So if they caught a bunch of tuna, in Port A, a bunch of fishermen showed up with tuna, they don't go to that port. They go to the port down the road that didn't have any tuna that day, because they get a higher price for their product. Consequently, Another example of similar technology getting used in developing countries using mobile technology, and it's all SMS-based. It isn't even smart yet, and we'll get to smartphones in a moment, is Kenya, where there's a technology called M-Pesa, if you haven't heard of it. It's a text-based, I guess from a Western world standpoint, I'd call it Western Union type of approach, where there's no ATM machines, and so financial transactions are largely done by text-based transfer of money. So if you're an M-Pesa dealer, I would go to you and I would give you cash, and then you would send me a text message to my phone that would enable me to transfer money to either somebody I was working with, a relative, whatever, in another part of the country. I send them a text, and then they go to an M-Pesa dealer and pull out cash. Now we can think that's fairly crude, which it is, but I think as of last year, 25% of the GDP of Kenya was getting transacted using text-based monetary transactions on crude cell phones. This is all going to fundamentally change now because smartphone technologies are coming. We have clients right now, and we've been working on this for a couple of years, and bringing the cost of semiconductor technology down so that we could actually conceive of $75 smartphones running Android operating systems, and those will be in the hands of developing country this year, probably the next 18 months.
I had a discussion this morning of a situation in Afghanistan where women-owned businesses were being severely hampered because there was no cash transaction. They can't have bank accounts, no check, and so they could make the product. It was a saleable product. People wanted it. No way to conduct the transaction. So it sounds like you're, whatever you want to call that, PayPal Junior or whatever that's called.
We can't take any credit for that. It's just amazing to me that these kinds of disruptive things are happening outside of what we would consider. And the people that did this M-Pesa system, I happen to know because the technology actually emanated from the University of Cambridge, and we've got some relationship with them. Somebody was talking about small teams of people. This is a development team of 10 people that started this entire M-Pesa-based system. It was a small team, and they deployed it out. And Vodafone actually was an investor. So
one of the other things we've talked about is chip size, and you described the potential of having a chip the size of a dust particle, which sounds like the flea that played the violin stomped on the bar, but. Our view of the world is just that. We see sort of three buckets of computing, and one is driving towards literally semiconductors that will have some type of RF technology and literally be able to be put into paint. I mean, almost layered onto that small kind of distribution with network effects that we will be able to use that information. And they could be in common items, concrete. We've had people coming to us talking about concrete and all sorts of interesting medias that semiconductors would find their way into. So we on one side, we are driving towards this, extremely, extremely small, very low power to the extent that it really doesn't require an energy source, to be honest. An energy source as we know it today and can have lives of 10, 15 years. And on the other extreme, we've got to fix this data center problem because, as I said, we're just contributing to the problem. And the data center issue, it's not a huge impact today on overall power consumption. I mean, relative to motors, the woman was talking about motors today, it's actually quite small. So if we really want to fix the problem of energy demand, fix her problem first, and we're also interested in that. But this data center issue will become more and more impactful. Certainly as we both go global with mobile with phones that are smart, because we're going into developing countries. Unfortunately, they just don't have any power at all. And so if we're going to put smartphones in there and they're going to have servers, they need power. So that's a problem, which we want to help fix. But also, the sensor world in developing countries will also be critical. Well, we've talked about the concept of the next digital planet. I'm just curious, in your head, what does that world look like?
So again, I think the way we're really working on trying to make sure we put the technology underpinnings on is this very adaptive learning environment that is this closed loop system that we're talking about. So I don't want to replicate what I was saying before, but that's an area of pervasive computing is another term that's used. That's an area that is very at the foundation of where we're focused, and that's an end-to-end solution. We want to make sure again that we drive the efficiencies at the lowest end with energy harvesting and all those kinds of unique things. But equally as important, the data center is going to be a huge either benefactor or it's going to retard that growth because of the energy demands that we're placing on it. We don't have enough power on this planet to keep up with our insatiable appetite for all this information.
You're telling me the impact on the New Jersey real estate prices of people building these data centers so close to the stock exchange they can't wait for electrons to go 6 blocks down the highway.
Well, yeah, we're seeing that, right? I mean, I don't know, high-speed trading. I mean, we talk about control loops, right? High-speed trading with algorithms right now. The price of real estate in Secaucus, New Jersey, is more expensive than it is Manhattan, just because the building next to the New York Stock Exchange's primary trade floor is within feet. So the speed of a transaction in a nanosecond could make somebody hundreds of millions or billions of dollars. So that's why they put them right next to it. So we're seeing it on a big scale. We're seeing this technology on so many different vectors. Cars. I look at automobiles a lot, and we've been fortunate as a mankind to drive down the fact that the mortality rate on 100,000 miles of driving is actually quite small now, and has dropped significantly if you were to track that over the last 25 years. Most of those advancements were made on safety systems in the car. You get in a crash, airbags deploy, we wear seatbelts, things, maybe ABS brakes. They're all sort of inside the car. But now what's happening, and you can see this in the Google car, Vin's here today, but now we're seeing that the cost of technology is coming down so low, all driven by semiconductors, that now it's about avoiding the crash altogether. Now we're at another world. Now we're not talking about inside the box. We're talking about outside the box. So you see it. I mean, everything from blind spot indicators, but more importantly, the Google car actually adjusts. Not only does it know where it is on the lane, but it tries to keep itself out of being blind spotted. It's avoiding blind spots. We see this with some of these adaptive radar systems that are in cars now that are keeping you out. The Mercedes. I saw a Mercedes ad today. If a kid runs in front of you and if something comes in front of you, it'll actually slam on the brakes. Driver alert and determining if your head's in the right positioning. I mean, these things this is today. So now we're moving from making the car safe when it's in a crash to keeping it out of a crash altogether. So we're going to see just more and more of that as the cost of semiconductor technology becomes more and more pervasive and drives down the cost.
Well, it's clear the world wants a lot more of what you do. Let's talk a little bit about the technology of what you guys have done, particularly with respect to 3D configurations.
Yeah, so for those of you who don't know, semiconductors have always been built using what would be called a planar structure. Semiconductors are essentially built upon a photographic process to many degrees, where you use mass, you expose light onto a device, you implant things, and you build it up. It's a two-dimensional planar type of process. That is running out, basically, in our ability to continue driving down the performance and cost of semiconductor technology. So just this year, or maybe last year, Intel is the innovator in this as far as making products, has created the latest breakthrough, which is called FinFET in the industry, but it's basically producing transistor structures in a three-dimensional fashion. So that at the most advanced side of the computational engine, that type of technology is now becoming mainstream. It's a fundamental change. Probably the previous fundamental change was when the semiconductor industry went from bipolar transistors to CMOS transistors, which happened, we'll call it in the 80s. This is a massive change that has now just begun, and that will be with us for 2 or 3, 4 generations of more technology. We're now at 22 nanometer devices, which is pretty darn small. So that'll be with us for probably down to 7 nanometer devices, which is probably four generations of technology ahead of us. A good long time. I'll be done by then. At 53, I'm sure I'll be done. And then we'll move to the next level, and I'm sure the scientific community will create solutions to that problem.
So, in going to the 3D, how big is X? Is this 5 times, 10 times capability? Exactly how you measure this? How high is up?
Yeah, so, Moore's Law continues to live. So we double the compute technology about every 18 months. And this continues down that path. Again, probably the biggest change that's happened is that we now, and really our customer base now, is moving in how they design semiconductors in general, which is we see the next evolution of semiconductors, and it is what's called system on a chip technology. And so what that means to layman's, if you would, or casual people is when products first come out, you basically have a general purpose processing element, and then you use software to run different algorithms. Some of those algorithms actually, if you're concerned about power, which again, this is sort of the foundation of who we are, some of those algorithms are actually better run in hardware, not in software, because they are more energy efficient when you run them in hardware. It's just purely an energy efficiency issue. So if you remember in our world, which came out of the cell phone world, when audio first came onto cell phones, when you could actually play audio, which was almost ringtones and simple things, there wasn't much audio there. But it was all run on a common CPU core, which is ARM, and then there was some processing algorithms that were done. Now anymore on audio, you don't run that on the CPU core. That's all accelerated in hardware. You don't run the graphics would probably be the next big thing. Graphics used to be done to a large degree on the CPU core. That's not done anymore. There's a separate block altogether that runs the graphics. So now we see this world sort of in the computer area or in the handheld area of what we call heterogeneous computing, which are multiple blocks on a chip that enable us to drive down the power. And the reason you can have an iPhone today or you can have an iPad today from a semiconductor standpoint is predominantly driven by the fact that we've been able to integrate more and more of these functions and to create specific compute blocks that just do a function very, very well. Or else your battery wouldn't last very long if you were playing movies.
So, the tough question I have for you. In your opinion, is the next digital world that you see on the horizon a better place for everybody?
Yeah, it's a different place. I don't know. That's a very good question. I'm not... certainly we all believe probably in democratization is a good thing, and that certainly has its benefits, although we look at what's going on in Egypt as the path to democratization has been challenging, or Syria or countries like that. Healthcare certainly will live longer, but a lot of people won't as we suck more water out of the aquifers. So I think it'll be a challenging place. I think it'll be rich for lots of great ideas. I think it will be better for business in many cases, but I think it'll be a challenging, interesting, exciting place.
You had a story about what's happening in China as they start to apply some of these technologies to the agriculture business, and that was a scary kind of a concept to me. What's the story?
Yeah, so I actually had the opportunity to spend some time with John Huntsman, who is a former ambassador to China for the U.S., and he was saying that the unwritten rule within China, they have their 10-year plans, but the thing that concerns them most, actually, as a country, is as they go to becoming more and more advanced, agriculture in itself, as they approach more modernized standards, will produce 600 million unemployed farmers. And they don't know what to do about it. They literally don't know what to do with the fact that as they've gone from small local plots to more modern farming mechanisms to feed their people, how this is going to have an impact on their society. And I think we're going to see more and more of those kinds of massive changes, I think, on a global level, largely driven by all the things we do in this room.
Likewise, we've talked about the impact on students and education from all around the world, having access not just to the same classroom material, but maybe even to the same classmates via technology that completely changes.
Yeah, that's great. Right? It levels the playing field for everybody. Right? We've got a number of Linux providers that do coding for us. These guys are located all over the world. We just care about the best and brightest. We don't care what country they're in. We don't care where they're at. And now you put into a $50, one laptop per child, which was a great program that was conceived several years ago, is now reality. It's called an Android smartphone, and it costs $50. And it doesn't take an institution to provide them. It can be provided by most of the carriers around the world. So all these things are going to be great levelers and provide great opportunity.
Before I throw it open for some questions to the audience, I'd like you to share your funny experience in Europe recently where maybe the smartphone wasn't quite as smart as it thought it was when you're checking in for this flight.
Yeah, there's an example where big data isn't quite there. So my last name, if you've looked at it, is very strange, 6 consonants in a row, and Germanic in nature, and so I was checking in on BA on my smartphone app to check in for my boarding pass, and as part of the check-in process, some smart, intelligent programmer has probably recognized I was in the UK, so I was in Europe, and I've got this funny last name that looks Germanic. So immediately when I went into the check-in process, it transferred me over to an all-German application, which I don't speak German. So again, there's an example where we didn't quite get it right. But
Okay, we will close on that one and open it up for some questions. We got a few minutes to take some questions.
Ty Carlson with Amazon. A couple of questions. Very interesting talk. Talk about scaling the Moore's law, and talk about 7 nanometer lithography and that capability. And we're talking, we can count the atoms on maybe 1 or 2 hands at that scale. So there's some real limits I think that we're approaching. Could you comment on what you're seeing with respect to EUV and what type of scale that you're being asked to design systems at? Or at least be able to design, because the design rules are getting to be onerous at best. You're literally on an exponential curve.
yeah.
And are we really going to, I really question Moore's law continued scaling here in the next few years.
That's a great question. Let's talk about deep EUV. So that's, for those of you who don't know, it's a process that's used by the production of wafers to actually create photographic process on a wafer because the waves themselves, the wavelength is actually larger than the feature size in some cases that we're drawing. So the guys that do all this stuff are some really, really smart guys that work on double patterning to 2 different light sources. Well, I know. I wasn't going to go there, but yeah, exactly. So deep EUV, that is a technology that is incredibly expensive. The throughput through the factories is poor.
Yes.
So it is at a point in time right now of limited rollout, I guess I would say. It will come, but the power of the lasers, as you probably know, to do that is massive.
They're 0.2% efficient.
There you go. You have it well. You're well educated on the subject. It'll happen. It'll happen. The throughput needs to certainly get up there, but we'll until that time, they'll continue to create interesting tricks. Now, on the Moore's law question, I agree with you. I think it'll slow down. I think it'll slow down because I don't think it's needed. Actually, part of it will slow down because technologically, economically, it's going to be impossible to keep up on that path, which is likely. I think also, I think it's going to be less needed. And we talk to your company a lot on data center stuff, for instance, and we think that there are a lot of architectures that can be deployed to do things that typically were done one way, they can be done another way. So this drive for performance and speed on a CPU only is probably not the biggest issue that really our customers or their customers face. So I think some of the pressure to continue driving that will also decrease, so it'll slow down from that perspective.
I notice you're working with AMD in some capacity as well.
Yeah, so AMD is a licensee of ours, and Andrew Feldman, who's just recently quoted and publicly talking about it. It's interesting because we sell a processor core that competes against x86. Clearly, AMD's been an x86 house for a long time. And the reason that they are beginning to come and use our technology isn't so much about the instruction sets that are run on our core versus on their core. Because to be honest, over time, again, smart guys will get to the same place, maybe a little different, but you put enough smart guys on solving an energy problem on the CPU architecture, they'll all get to the same place. The reason that they're interested in us, and it's become sort of what ARM is much more about our business model, which is allowing innovation and driving the cost down on innovation. So the fact that we have 7 or 8 people that are going to be doing server-based chips that are optimized for specific examples drives down the cost of server chips. These are his numbers, not mine, from $300 million to $30. Now, when you do $30 million server chips and you can make money at doing $30 million server chips, you can obviously allocate that over a smaller amount of products. But more importantly, you can address specific issues for customers that are unique to them. And what we are seeing with just the data center specifically is, we'll take Facebook, for example, who was involved in when we made our AMD announcement we had Facebook on the stage with us with Open Compute. But more importantly, they were talking about, it was the day before Halloween, and they were talking about the number of photos that were going to be uploaded that weekend. 3 billion. 3 billion photos that people have taken with their cell phones were going to be uploaded over last Halloween weekend. That is amazing. Now, what's more amazing is they never throw these things away, which should either scare you, in my case, or my 18-year-old son probably should, doesn't probably yet, but it should, or, it's just amazing. So what they are now designing data centers, in the case of Facebook, and probably Google's doing the same, that are fit for purpose. And the fit for purpose in this case is just storing pictures. So it's not a generic thing at all. It's purely storing pictures. And what do they want to do? They want to shut those things down as hard as they can until you need to retrieve it. But they want to offer you the opportunity to retrieve that Halloween picture you took in 2006. They really don't care if it takes you 300 milliseconds longer to get it, because you probably won't know, but they do want to make sure that the cost to contain that issue is under control. So they're developing server technology, in this case, that just shuts itself down until you need to do these retrieval times. And this is the kind of stuff that we see happening. It's really fit for purpose stuff. And that's what we're in the phone business. I mean, the reason, again, Apple does what they do in iPhones is it's fit for purpose. And we see our role as having a common core with a big software base that lots of people can leverage off of enables that type of work. And that's really what ARM's all about now. So, did I answer your question?
Sure.
Yeah, sorry.
Yeah, sorry, Roger Payne. I'm interested in your 600 million unemployed farmers from China. I realize that's not your doing, but
it's not mine.
It's an interesting story.
We create it
That's
somehow.
Twice the population of the United States, 4 times the population of Japan. That's a big problem.
It is.
And my feeling is maybe that means that everywhere this effort is going is headed in the wrong direction. That in fact what would be, not your effort, excuse me, but what's happening in places like China with that kind of problem coming down the pike is that maybe they're headed in the wrong direction on the pike. And that what needs to happen instead is something that keeps those 600 million farmers in business, operating on farms that are small, which is historically speaking, the only way that cropland has remained sustainable over long periods of time and actually improved instead of being deproved. Sounds like a disaster to me, but thank you.
Well, that's why I asked, is it a better place or not? I struggle with this, right? For the very purpose that you know, for the very reason that you're talking about. I mean, you know, I can have my own personal view on this, which, you know, I like to support local farmers and, you know, but you pay a premium for that today, right? I mean, it amazes me today. I live in Palo Alto, California, and there's a great farmer's market and certainly an abundance of production of, you know, fresh fruits, vegetables, you name it in California. That being said, it's cheaper. It just blows my mind. You go to something like a Trader Joe's, and it's cheaper to import peppers from Chile, a green pepper. You know, I mean, I scratch my head and wonder how this can be, but clearly it is. So, you know, I mean, we as a population, unfortunately, don't support that. But I agree with you. I mean, you know, you know, we have created a massive business, and I'm not an agricultural guy, but there's huge businesses associated with that.
We got time for one last fast question. If there's nobody there, I will thank Tom
Great.
for
Thank you.
being such a great resource.